Close your eyes for a moment. Actually, don't. You're probably driving or running or doing something that requires vision, but imagine closing your eyes. Now, feel time passing. That sensation you have of being in this moment, with moments behind you and moments ahead. That feeling is so fundamental, so obvious that questioning it seems absurd. But here's what physics says. That feeling might be a bug. Einstein showed us that time isn't constant. It stretches and compresses depending on how fast you're moving, how deep you are in a gravity well. Your GPS satellites experience time differently than you do. They have to correct for it, or your navigation would drift by kilometers per day. But that's just relativity. Here's something stranger. Some physicists argue that time doesn't flow at all, that past, present, and future all exist simultaneously, frozen in a four-dimensional block. Your experience of moving through time? An illusion, a persistent glitch in how your consciousness processes reality. As a software engineer, I know what happens when a system's model of reality doesn't match actual reality. Race conditions, deadlocks, systems that think they know what order things happened in, but they're wrong. What if your entire experience of time is exactly that kind of error? The most fundamental aspect of your existence, your sense that moments pass, that you move from past to future, might be an artifact of how your brain processes information. A persistent illusion that evolution selected for because it's useful, not because it's true. Welcome back to Code, Cosmos, and Chaos, where we drag the biggest questions of existence into the harsh light of a code review. I'm Chris. Last episode, we explored the Fermi paradox and whether AI might be the great filter that wipes out civilizations. Today, we're going even more fundamental. We're questioning time itself. Is time real? Does it flow? Or is the universe more like a completed movie that already exists on a hard drive? And consciousness is just the playback head scanning through frame by frame, creating the illusion of motion? We'll explore the block universe theory, the arrow of time, what neuroscience says about how your brain constructs temporal experience, and why, from an engineering perspective, time looks suspiciously like the universe's most fundamental race condition. Before we dive into modern physics, let me take you through 3,000 years of humanity wrestling with the nature of time. Because this is not a new question. The ancient Greek philosopher Heraclitus said, "You cannot step into the same river twice." Everything flows. Change is the only constant. Time moves, and so do we. But his contemporary, Parmenides, another Greek philosopher who founded the Eleatic school, disagreed. Change, he argued, is an illusion. Reality is eternal and unchanging. What we perceive as past and future are merely aspects of a static whole that our minds cannot fully grasp. This debate between becoming and being, between time that flows and time that just is, has continued for millennia. Augustine of Hippo, the early Christian theologian and philosopher whose ideas shaped Western thought for centuries, asked in the 4th century, "What then is time? If no one asks me, I know. If I want to explain it to a questioner, I do not know." He struggled with the paradox that the past no longer exists, the future doesn't exist yet, and the present is merely the boundary between them. How can time be real if none of its parts exist? Newton gave us absolute time, a universal clock that ticks the same for everyone, everywhere, providing a fixed background against which events unfold. This was the common sense view, and it worked beautifully for centuries. Then Einstein shattered it. Time, he showed, is relative. It bends with gravity, it slows with velocity. There is no universal now. Your present moment and my present moment, if we're moving relative to each other, are fundamentally different slices of reality. But Einstein left us with an even stranger implication, one that physicists are still debating today. Let's start with what physics actually says about time, because it's weirder than most people realize. In 1908, the mathematician Hermann Minkowski gave a famous lecture where he said, "Henceforth, space by itself and time by itself are doomed to fade away into mere shadows, and only a kind of union of the two will preserve an independent reality." What he meant was that Einstein's relativity showed us that space and time aren't separate things. They're woven together into a single four-dimensional fabric, space-time. Now here's where it gets philosophically wild. If space-time is a unified thing, if the future is just another direction, like left or up, then maybe all of space-time already exists. Past events aren't gone. Future events aren't yet to happen. They're all just there, existing simultaneously in a four-dimensional block. This is called the block universe theory, or eternalism, and it's taken seriously by a significant number of physicists and philosophers. But it's not the only view. Presentism argues that only the present moment exists, the past is gone, the future isn't yet, and now is metaphysically special. The growing block theory offers a middle ground. The past and present are real and fixed, but the future is genuinely open, being added to the block moment by moment. Each view has defenders among serious philosophers. Physics alone doesn't settle the debate. The equations are compatible with multiple interpretations. Einstein himself hinted at this. In a letter after his friend Michel Besso died, Einstein wrote, "The distinction between past, present, and future is only a stubbornly persistent illusion." Think about it like a movie file on your computer. The entire movie exists all at once, beginning, middle, end. It's all there in the file. When you watch it, you experience it sequentially, one frame at a time. But that's just how you're accessing it. The movie itself isn't becoming. It already is. If the block universe is right, then you listening to this. Your childhood birthday parties, your eventual death, they all exist right now, eternally, frozen in the cosmic block. Your consciousness is just moving through it somehow, experiencing slices of the block sequentially. The obvious question is, why does it feel like time flows? Why do we experience a now that seems to move from past to future? And the disturbing answer from block universe proponents is, we don't know. But that doesn't make the block less real. But wait, if all of time exists simultaneously in a block, why do we only experience it going forward? Why can we remember yesterday but not tomorrow? Why does the arrow of time point in only one direction? Here's the thing. Almost all the fundamental laws of physics are time symmetric. If you filmed particles bouncing around and played the video backwards, you couldn't tell the difference. The equations work the same way in both directions. There's only one major exception: entropy. The second law of thermodynamics, we talked about this in episode 4. Entropy always increases. Order always degrades into disorder. Eggs break, but don't unbreak. Coffee cools, but never spontaneously reheats. This is what physicists call the thermodynamic arrow of time. It's the reason we know which direction time goes, because entropy tells us. But here's the puzzle. Why was entropy ever low in the first place? If the universe started in a high entropy state, there'd be no arrow. Everything would already be as disordered as possible. No change. No time direction. The fact that the early universe had extremely low entropy, was incredibly ordered, is called the past hypothesis, and no one fully understands why it's true. A 2024 paper from Cambridge University Press reconstructed different ways entropy might ground the arrow of time, identifying 3 distinct possibilities: an empirical arrow based on observation, a universal statistical arrow and a local statistical arrow. The debate continues. And there's another wrinkle. In March 2025, researchers published work on reshaping the quantum arrow of time, showing that with the right quantum control, you can create dynamics more consistent with time flowing backward than forward. They're not reversing time, but they're showing that the arrow isn't as fixed as we thought. From an engineering perspective, entropy looks like something I've seen in every large system I've worked on: technical debt. The system starts clean, ordered, well-designed. Then entropy creeps in. Complexity accumulates, order degrades, and there's only one direction it goes. So, physics is ambiguous about whether time flows. But what about your brain? How does the 3 pounds of meat in your skull create the experience of moving through time? Here's the first thing to understand. There's no clock in your brain. No single structure that measures time the way a watch does. Instead, time perception is distributed across multiple neural systems, each handling different timescales. Milliseconds to seconds, that's handled by dedicated neurons in early sensory areas. Seconds to minutes, the prefrontal cortex and basal ganglia take over. Hours and days, the hippocampus, which also handles memory. A July 2024 study from UNLV published in Current Biology made a fascinating discovery. We don't perceive time based on some internal clock counting seconds. We perceive time based on the number of experiences we have. The brain tracks events, not duration. This is why time flies when you're having fun. Fewer distinct events get encoded. And why boring meetings feel endless. Every painful moment gets recorded separately. The researchers found that as the brain progresses through tasks, different groups of neurons take turns, like runners passing a baton in a relay race. Time perception emerges from this handoff pattern, not from any central timer. A 2024 scientific reports collection on malleability and fluidity of time perception documented how subjective time can stretch and compress based on attention, emotion, and even the properties of stimuli we're perceiving. Time isn't something we passively observe. It's something we actively construct. And in February 2025, researchers at MIT and Harvard proposed a new time domain brain theory, arguing that the brain uses time delay networks, wave interference processes, and oscillatory sequences to create temporal experience. Time, in this model, isn't perceived, it's computed. As an engineer, this resonates deeply. The brain isn't measuring time, it's modeling time. Constructing a representation based on available data. And models can be wrong. The physics and neuroscience of time are both active research frontiers. Here's what's happening right now. First, in April 2025, a paper in the journal Theoria presented a new account of temporal passage compatible with the block universe. The researcher argues that the passage of time can be grounded in the relationship between entropy boundaries and how entities occupy different moments in the block. This matters because it offers a way to have both: a block universe where all times exist, and a meaningful sense in which time passes. Second, the 2024 research on the quantum arrow of time from Gruber and colleagues concluded something fascinating. The brain may have evolved 2 separate systems for experiencing time. One system gives us veridical, accurate experiences matching block universe physics. The other gives us the illusion of flowing time, which natural selection preserved because it's more functional for everyday survival. Think about that. Evolution may have given us a broken clock on purpose because a working clock wouldn't help us survive. Third, a June 2024 paper explored the connection between block universe theory and artificial intelligence. The researchers argued that AI's ability to process temporal data timelessly, analyzing past and future simultaneously, makes it an embodiment of block universe principles. AI, in a sense, already experiences time the way physics suggests it really is. Fourth, in August 2025, a new super special relativity framework proposed that perceptual time is distinct from physical clock time and depends on the brain's computational capacity. When you're processing more information, time subjectively slows down. This is why life-threatening moments seem to stretch. Your brain kicks into overdrive. And fifth, ongoing research into gravitational effects on time shows that even gravity creates separate arrows of time. A 2024 paper on gravitational entropy found that the gravitational arrow might actually point in the opposite direction from the thermodynamic arrow in certain conditions, suggesting the universe might have multiple conflicting time directions, depending on what phenomena you're tracking. Okay, let me bring this back to engineering because I think there's something profound here. A race condition happens when a system's behavior depends on the sequence or timing of events, and that sequence isn't guaranteed. Two processes access shared data. The result depends on who gets there first. And if you don't handle it carefully, you get inconsistent states, corrupted data, systems that think one thing is true when something else is. Here's my thesis. Human consciousness might be a race condition. Think about it. Your brain is a distributed system, billions of neurons, no central clock, signals traveling at finite speeds. Different parts of your brain receive information at different times. Your visual cortex, auditory cortex, prefrontal cortex, they're all processing the world on slightly different timescales. And yet you experience a unified now. Everything seems to happen at the same time. The car horn honks and you see the car simultaneously. Even though light and sound travel at vastly different speeds, even though your brain processes them in different regions, your brain is synchronizing asynchronous inputs to create the illusion of simultaneity. It's doing clock synchronization without a master clock. And when that synchronization glitches, as it does in certain neurological conditions, your experience of time fragments. Events seem out of order. Causes follow effects. Maybe that's why the block universe feels so wrong to us, even if it's right. Our brains evolved to construct flowing time because that construction solved a practical problem. How do you coordinate a distributed system with no central authority? You fake it. You create a shared illusion of sequence. You impose order on events that, at a fundamental level, might not have an inherent order at all. In distributed systems, we call this eventual consistency. The system doesn't guarantee that all nodes agree at any given moment, just that they'll eventually converge on the same state. Maybe consciousness is the same thing. Not an accurate perception of time, but an eventually consistent story we tell ourselves about what order things happened in. And if that story is wrong at the deepest level, if time really is a frozen block and our experience of flow is a bug, not a feature, then what does that mean for free will, for causation, for everything we think we know about reality? So where does this leave us? Honestly, nobody knows whether time really flows or whether we're frozen in a block universe experiencing the illusion of change. The physics is ambiguous. The philosophy is contested. The neuroscience shows us that whatever time really is, our experience of it is constructed, malleable, and deeply strange. But here's what I find beautiful about this. Even if the block universe is true, even if past and future already exist, frozen and eternal, the experience of now still matters. This moment, as you're hearing these words, is happening for your consciousness. The experience is real, even if the metaphysics is weird. And maybe that's enough. Maybe the question isn't whether time really flows, but what we do with the flow we experience. Whether it's an illusion or not, it's our illusion. It's the stage on which everything we care about plays out. The block universe, if true, means that somewhere in space-time, you're always being born. Somewhere, you're always dying. And somewhere, you're always listening to this podcast, pondering the nature of time. That's either terrifying or comforting, depending on how you look at it. Me? I find it strangely peaceful. The code is already written, we're just running it. And as an engineer, I know that the most interesting things happen during runtime. Even if the program is deterministic, the experience of execution is where meaning lives. Thank you for spending your precious temporal resources, however real or illusory they may be, on episode 6 of Code, Cosmos, and Chaos. If you're now questioning whether your deadline is actually in the future or already exists in the block universe, congratulations. You've reached the right level of existential uncertainty. Subscribe wherever you get your podcasts and leave a thumbs up or review if you exist in a timeline where you enjoyed this. Hit me up on X at Code Cosmos Chaos. Do you think time flows, or are we frozen in a block? Does the block universe comfort you or terrify you? I want to hear from all your temporal instances. Next episode, we're asking whether you might not exist at all. Boltzmann brains, the statistical argument that you're more likely to be a spontaneous fluctuation in the void than a real person with real memories. It's going to get weird. This is Chris, logging off from somewhere deep in the stack. Until next time, keep debugging reality, one moment at a time.